This is Module 8, Procedural Languages. Objectives. In this module, we will start with PostgreSQL procedural languages topic, in which we will talk about different procedural languages available inside PostgreSQL and also talk about how we can load or install particular procedural languages. After that, we have a topic of Introduction to PL/PGSQL, in which we will talk about how we can load PL/PGSQL inside PostgreSQL database, and then we'll talk about how we can use it, in which we will talk about how it works, what are the block structure of PL/PGSQL, how we can declare variable, how we can write executable statements inside PL/PGSQL block structures, how we can declare function parameters, how we can create control structures like if, else, or while loop. We'll talk about exception handling also, and PL/PGSQL cursors also, and then we will talk about triggers. All these things are done using PL/PGSQL language in PostgreSQL. In PostgreSQL, we can create user-defined functions using different languages. A function is compiled and stored on the database side and can be shared among multiple applications or users. A user-defined function can also save your application from extra round trips between client and server, as it is stored on the server side. So whenever the client need to execute a particular query and do some calculation and then return the result to the user, so in this case we will do the calculation on the server side, because database functions are executed on the server side. So they are going to use the resources on the database server side, not on the client or the web server side. So if any time your business logic needs to be put at one place where you want it to be shared among multiple applications, and you want to save yourself from extra round trips between the network, between client and server, you can create functions using a procedure language in PostgreSQL and store it on the server, and again it is compiled and stored on the server side. Another advantage of using a function is that instead of granting permission on individual tables to the user, we can actually grant a permission of permission to execute a function to a particular user, and that function is using those database tables. So in PostgreSQL, there is a property of a function known as execute using the invoker context or using the definer context. So if we create a function with a property known as security of definer, then that function is executed using the properties, using the privileges of the user who has created that function and not who is executing that function. So we have a DBA user who have access to all the tables, and using that DBA user we can define a function which can access all the tables and do the work, or perform the entire logic using the DBA's privileges. So we define it using a security of definer parameter, and then we give execute privilege to a normal user. So normal user will execute that function, but it will execute in the context of the DBA user. So this way, the normal user who does not have access to the tables directly can execute that particular function, and he will get the result. So you are adding a security layer between that user and the server. This is an added security layer that you can put using database functions only. So these are some of the advantages. Now, seeing these advantages, you might decide that you want to create some procedure languages, maybe because of the performance benefit due to the extra round trips, maybe because of the centralization of your business logic, or maybe because of the added security feature in PostgreSQL. So whatever the reason is behind your decision of creating procedural using procedural language on the server, you need to create functions for that. So functions can be created using different procedural languages. You can use PL/PGSQL for creating a function. You can use PL/TCL, PL Perl, PL Python, PL Java, PL Ruby, and you can also define your own language, load the handler of that language onto the server, and use that language. Later in this training, we will cover how we can associate a language handler with the database server so that we can create functions using that particular procedure language. Introduction to PL/PGSQL. PL/PGSQL is one of the many languages that are available for creating functions inside PostgreSQL. It is an extension to the PostgreSQL language. Using PL/PGSQL, you can create functions in Postgres and you can create trigger procedures. PostgreSQL does not support creation of procedures. When it comes to difference between a function and a procedure always returns a void. So if you create a function which returns a void, which is possible in Postgres, that gives the same functionality that a procedure will give. But in PostgreSQL, we cannot create procedures. So PL/PGSQL language can be used to create functions and trigger procedures. Trigger procedures are special functions which are used by triggers only. Now, PL/PGSQL is an extension to the SQL. That means it adds some capabilities inside your SQL query language. So what it adds actually is it adds a control structure. You can perform complex computations using PL/PGSQL. You can use all the user-defined data types. You can use all the available data types inside PostgreSQL, all the available functions and operators inside PostgreSQL. You can use all of them inside PL/PGSQL functions. The PL/PGSQL functions can also be defined to be trusted by the server, and it's quite easy to use. If you are already familiar with PL/SQL of Oracle or TSQL of SQL Server or any other procedure language of any other database, it will be quite easy for you to understand PL/PGSQL because it comes with very basic structure and very basic keywords used to create different types of structures, different types of blocks inside PL/PGSQL functions. So let's now learn how we can use PL/PGSQL. How PL/PGSQL works. PL/PGSQL functions are compiled and stored on the server side. So if you look at this diagram, there is a server at the bottom where your PL/PGSQL function is compiled and stored. It's error-free function stored on the database server side. Now, on the server side, we have a SQL engine, let's say PostgreSQL SQL engine, who understands structured query language. That means this SQL engine cannot understand your if statement or your while statement, or cannot understand declare statement where you might declare some variables. It only can understand query language, that is structured query language SQL. Now, when it comes to using a function and when we run that function, what happens at the backside is to add a function inside Postgres, we actually associate our PostgreSQL database with a particular language handler. So in case we are using a PL/PGSQL function, we will have an association between our SQL engine and PL/PGSQL language handler. This particular language handler is actually kind of an interpreter who understands PL/PGSQL, who understands the procedural language. Now, on one side, SQL engine understands only SQL. On the other side, PL/PGSQL language handler understands only PL, that is procedural language only. So when a function is executed on the server, the function first of all goes to the handler. The handler take out the entire PL inside it. That means the looping structure, the case, or any other procedural language that you have used, it will be taken out of it, and it will go to the PL/PGSQL executor. Now PL/PG executor will execute those particular statements, and anytime a SQL query is referred, a SQL query is used, let's say you have a while loop, and in the while loop you are inserting lots of rows, so you're using same insert again and again. So where that insert will go, automatically the insert will go to the SQL query engine, and SQL query engine will work on that insert, return the data back to the user, that is how many rows affected. So the information will be given back to the PL/PG/SQL handler. So your PL/PG/SQL handler takes the function, according to the PL inside that function it executes the entire SQL, and finally it combines the entire result and send it to the user. That's how PL/PG/SQL or any other language, any other procedure language will work inside PostgreSQL. PL/PG/SQL is a block structured language. That means whenever you create a function using PL/PG/SQL procedural language, the function definition or the body must be defined using blocks. You can use declare block to declare variables that you might want to use later on in that particular function, cursors, user defined exceptions. So these three things can be defined inside the declare block. The next block is begin and end. This is a mandatory block. A function must have at least one begin end block. This block can be nested also. The begin block marks the beginning of the function, and inside begin block you can write your SQL query. You can write the SQL statement. So the entire structured query, language query can be written inside this particular block, and you can also use different PL/PG/SQL statements inside begin end block. Exceptions block is an optional block inside begin end. It must be used at the end and just before the end statement. So in this block we handle runtime errors. So whatever action that we want to perform at the time when there is a runtime error on the server, we can do so by using exception block of PL/PG/SQL. As I said that inside the declaration you can declare variables. So when you are declaring variables, the statements must be ending, the single variable declaration must end with a semicolon. And all the statements that you write in these particular PL/PG/SQL blocks must end with a semicolon. At the end of the last end statement you can skip that semicolon. That semicolon is an optional, but if you are using blocks inside a block, like you're using sub blocks, let's say you say begin and then another begin and then you say end and then another end. Now the begin end block, which is inside the previous block, which is nested begin end, that particular block must be ended with a semicolon. So you have to write semicolon after that particular end. Other than that, you can skip the semicolon at the last end that you're using in a particular PL/PG/SQL function. It is always recommended to use semicolons after all the statements, and even after the end block, even if it is optional. So this way you can create a PL/PG/SQL function using different blocks which are available. Again, declare block, begin, end block, and exception block for handling runtime errors. PL/PG/SQL structure. All the keywords, identifier, variable names, all the table names, anything that you write inside the function body is automatically converted to lowercase. It can be written using mixed case. You can use upper lowercase letters inside variable names, but when the function is executed, everything is converted to lowercase. If you want the names to be case sensitive, you have to double quote those names. So put those names inside double quotation which you want to be case sensitive. Inside PL/PG/SQL you can define two types of comments. You can give a single line comment or multi-line comments. Comments are sometimes necessary to be given in PL/PG/SQL blocks so that we can take a look at the block and understand what it is doing, and it's normal practice done by all the developers that comments are used inside your programs. So when you want to use a single line comment inside PL/PG/SQL block, you can use double hyphen. And if you want to give a multi-line comment, you can start the comment using /* and end the comment using */. This way you can define comments inside PL/PG/SQL body. Variables. Variables are used for the temporary storage of data. They can be reused inside the PL/PGSQL begin and end block. To declare a variable, we use the declare section where they can be declared and initialized. We can use and assign the new values to this variable inside the begin and end section. We also call this as executable section. You can also pass the value of a variable using the function's parameters. So they can be used inside the parameters also for handling the input parameter, and they can also act as output parameter in a function. We can create variables using any valid SQL data type. So a variable needs to have a data type, and in PL/PGSQL you can define a variable of any valid SQL data type available in PostgreSQL. You can also create a variable with a default value or with a constant clause. Declaring variables. Here are some examples how you can declare variables in PL/PGSQL. User ID is a variable of integer type on this slide, so name of the variable and the data type. Then the second variable here is quantity with numeric and 5 size, that is the precision. URL is a variable of varchar type. myRow is a variable of a row type. Now row type, type and record, these are three special types which are available in PostgreSQL. Row type is used to create a variable which can store one single row of a particular table. It is a bound type, means it is bound to a table with whose name you will specify at the time of declaring that variable. So if you say myRow EMP percentage type, you are declaring a variable myRow of employee row type. It can store one row of employee table. If you say myRow and you say record type, then it can store one row of any table. It can be employee table, it can be department, or it can be any other table also. So this way, when you don't know the data type of the table columns, you can define a row type or you can define a record type. In case you want to create a variable for one single column value and you don't know the data type of the column, you can always use type syntax for that. So the example is given here: my field table name dot column name percentage type. This is used to define a variable of a particular column type. Then quantity integer default 32. So a quantity variable is declared there with integer data type, and the default value for this variable is 32. This way you can declare variables in PL/PGSQL. The syntax of declaration is also given at the bottom, where it says name of the variable. If you want to create a constant variable, specify constant before the data type. Then comes the data type of the variable. If you want to keep a not null value for this variable, you can specify not null. You can also give a default value by using default. Colon equals to is used for assignment of a particular value to a variable, and you can assign a value, expression, or a literal to a variable. So this is how you can declare variables in PL/PGSQL. To assign a value to a variable, we can use colon equals to operator. This is an assignment operator. So it's not just equals to, it's a colon and then equals to. So to assign a value, we say the variable name is colon equals to the value. The value can be the value itself or the expression. So it's a single literal that you specify, or you can calculate the value that will become an expression. In both cases you use colon equals to assign the value. Sometimes we assign the value of a variable from a table row data. So if you are retrieving the value of a variable using a select statement, you can do that using select into. You can say select into variable name, and then you specify the column list from table name, and then you specify your condition. Example is given on this slide for assigning values. In the first example, it's user underscore ID colon equals to 20. So value, that is the literal value assigned to a variable user underscore ID. Tax colon equals to subtotal multiplied by 0.06. So calculate the 6%, and that will be the tax variable value. Select into myrec, that is a variable name. multiplication symbol, that is asterisk, from EMP. So you're actually retrieving all the rows from EMP table, and you're saying that where EMP name is equals to my name. So that particular person's row will be retrieved by this select statement, and the entire row will go inside my rec variable. Here the my rec variable is of a record data type or row type. There is a local variable found which is available inside any PL/PGSQL function. It is local, so it is not shared among multiple functions or multiple sessions. For your session, for your function execution, you will see a found local variable available there, and this is a Boolean variable. It will be either true or false. This is quite useful and used inside your PL/PGSQL blocks frequently. Reason, because sometimes or most of the times we want to check that the previous statement that we had executed has affected some rows, or the previous statement that we executed has retrieved some rows from the table. We want to ensure the things before we can move on in a particular PL/PGSQL blocks. For example, if you're going to traverse through the result set, before you actually go to that particular traverse process, you want to ensure that you have retrieved some rows, that there are some rows inside the result set that you want to display to the user. If there is no row, then you simply don't want to traverse in there. You don't want to go inside the result set and do some work in there, because there is no row present in there. Who will tell you that whether there is any row or not? And that's a time when found is quite useful. Another example, let's take you inserted some rows inside the table. Now you want to ensure that insert was successful. So who can tell you that? Found can tell you that whether it was successful or not. So on the slide you can see that you can use this found keyword, and this found will be true in case the select into statement has retrieved some rows. So if you're using a select into a particular variable and retrieving some rows from the table and putting them inside a record variable, and if that record variable got some rows, that means some rows were retrieved, the found will be true. So you can use if found, then you move on to the next step, otherwise you exit from the function. If you are using a perform statement, which can be used to run a particular SQL query and just discard the result. Now once you discarded the result, you don't know what happened, whether the previous query was successful or not. In this case, the found is quite useful, because found can actually be true if the previous result was there which was discarded. If there was no result, then the found will also be false. When you do update, insert, delete, you get a message on the screen: one row affected, two row affected, no row affected. So if the message is no row affected, normally in PL/PGSQL you will not see that message. So found will tell you, if found is false, that means no row affected. If found is true, that means some rows were affected, which may be one or more. When you use a fetch statement inside a cursor and you're traversing in a cursor, let's say I can just give you an example here. The cursor is a component. It's a pointer to a result set, and you can traverse in that result set. So you have, let's say we have 100 rows there, and you are going from 1 to 100 rows, and once you reach 100 row, the found will turn to false. So you can use found keyword and keep on fetching the rows up till the time found is true. Once a found turns to false, you simply want to stop that processing. And the same is the case with the for loop also. Let's say you retrieved a lot of rows from the table and you are traversing using for loop, and you want to ensure that you are stopping, you're exiting the for loop once you don't have any row left inside that result set. You can do so by using found keyword, because it will turn false when the row is not found. So this way, this particular local variable is quite useful inside your PL/PGSQL functions, and it can give you true or false values, and quite helpful when it comes to see that whether the previous statement has affected any row or not. Executable statements. You can write executable statements inside a begin and end block. Blocks can be nested also. Statements inside a block can continue on several lines also, and whenever you want to end a statement, that statement must end with a semicolon. So if you're writing a select query inside a begin end block, that select query can go on to multiple lines also, and when you want to end that particular statement, then you can put a semicolon. So that entire line number of lines will work as one single statement inside a block. So you can write executable statements inside begin and end block. Function parameters. In PostgreSQL, you can define a PL/PGSQL function which accepts parameter as well as which returns parameters. So you can use in and out keywords inside the parentheses, and you can define a particular variable, or you can use $1, $2 also. These are the identifiers in a particular list you can define inside the parentheses when you are defining a function name, and you can define a variable as input variable or output variable. If you don't use in or out keyword, then by default the variables are input parameters, and if you want an output parameter, you have to say out and then variable name and the data type. All the parameters that you pass to a function must be of a valid SQL type. An example is given on this slide where we are using a subtotal as an input parameter. So create function sales text, that is the name of the function, and then in the parentheses subtotal, that is the name of the input parameter, and real is the data type of that parameter. You can also define it like create function sales underscore text, start parenthesis, in subtotal real. So you can say input parameter also. If you want it to be output parameter, you have to say out subtotal real. That way it will become an output parameters. Both types of parameters are supported inside PostgreSQL. I will show you some of the examples of these parameters. Here is our first PL/PGSQL example. So create or replace function sum underscore val I numeric comma z numeric returns numeric as $. $$ marks the beginning of the function body. The ending of the function body is also done by using $, and then you write language and the procedural language name in which you are writing that particular function. As I said that in Postgres you can create a function using different procedural languages, so whichever language you are using for this particular function body, you can write that language name after the at the end of the function with the language syntax, with the language keyword. So in this example, two variables I and z are input variables. Return type is numeric. This function must return a numeric value as $, body start, begin. So I'm not using any declare block here, simply begin, and return keyword can be used to return a value, return I plus z. So what it will do, it will calculate the sum of I and z and return that, because I is a numeric, z is a numeric, so sum is also a numeric value, and the numeric value will be returned. And then end, function is ended, the body is ended. So to mark the ending, again a $, language PL/PGSQL semicolon. This way you can create a function. To invoke this function from the PSQL or from your application, you can simply write select sum underscore val, and then you can pass two parameters. If you try to pass one parameter, this will not work because we haven't defined any of the parameter with default value. So we have to pass two values to this function, and we will get 30 in return. Let me execute this function and show you how you can create it using using PSQL tool, and how you can execute it. Example 2. In this example, we are going to pass two variables, two parameters to our differ function, and that function will subtract second from the first parameter and return the result on the screen. I want to see that result on the screen. So it's not going to return it, it's going to display it. So create or replace function, name of the function, differ, start bracket, x numeric, x is first variable that we are defining, then y numeric, second variable, returns void. Now the return type is void, means it is not returning anything. as, then the dollar dollar that marks the starting of the body. Now in this function I'm using declare section. So declare, there's no semicolon after declare. Then you declare the variable, that is D numeric. So one variable is declared and then semicolon. If you want to declare two variables, you can press enter, go to the second line, declare second variable, put a semicolon at the end. After that, begin block, and again there's no semicolon after begin block. Sorry, after the begin keyword. After that, I'm saying capital D is colon equals to, as I said, colon equals to is assignment operator, and I'm using here capital D, and I also explained to you that automatically everything is converted to lowercase unless you put it in double quotes. So even if I write D numeric, if I declare a variable D in small letters and then later on I use D in capital letters, it works fine. But if by mistake I put capital D in double quotes, then it will not work. So capital D colon equals to x minus y. So this will calculate that value, and that value will go to the variable D. Then I say raise notice. Raise notice is used to raise a notice message on the screen, and what message you want to display, you can put that message in semicolon, and if you want to put a placeholder, you can use percentage for that. If you are using a percentage and you put a placeholder, then you have to write a comma after the literal, and you have to specify the name of the variable whose value you want to display. So raise notice in single quote difference is colon percentage and colon close. So it's a single quote in which I have written difference is percentage, comma D and semicolon. So this will display the value of variable D. That is a difference between x and y. After that, return. So I'm writing here a return clause, but I'm not writing any value here. If I don't write return, the function will not work because function must have a return statement before the last end. So return semicolon and then end semicolon dollar dollar language PLPG If you want to use this function, you can say select differ 10, 5. It will return me 5, which is difference between 10 and 5. So this is an example too in which we used variable, and we used raise notice, we used return clause, and we also use void data type in this function. Let's now see a demo of how we can create functions in PostgreSQL. I'm going to start with the example one that I have discussed on the previous slide. So what I'm going to do is I'm going to connect with the server and run a script in which I have written create function statement. You can write a create function statement to create a function, as I already discussed that, and you have to run this particular script in the database where you want to create that function. Now first of all, I'm going to connect with the Postgres ADB store database and show you the structure and show you if there is any function already there, and then later on I'll come back and run the script that I have created. So let's go and connect with PSQL ADB store database and Postgres user here. I'm connected. You can write \df. That will give you a list of functions which are already there. Right now only some LO extension functions are there, but there is no function that I have defined. So there is no function yet on my server. I will create some functions now. By default, the function that you will create will go in public schema unless you have a user named schema. That means there is if you see on my server here, there is only public schema right now displayed here. I don't have any Postgres schema. If I have a Postgres schema, my tables will by default go inside the Postgres schema. That is normally the recommendation, that you have a proper schema in which you keep your tables and your functions and other database objects. Now let's come back and let's try our example one. I'm going to quit from this terminal. I have written some scripts inside PGSQL demos directory. These are the scripts that I will be using throughout this training. So there is a script for sumval function that we discussed in the example one slide. This is a sumval.sql. I can show you what I have written inside that. So you can write this script, or you can write the create function directly on the PSQL. You can write this create or replace function directly inside the query tool also. So it's your choice that where do you want to write this script, where do you want to write this create statement. I have written it inside a particular file, and I will execute this file on the server, and that will create a function for me. The script is create or replace function sumval. numeric, z numeric, returns numeric as $$ begin, and then I say return I plus z, so it will return me the sum of two numbers. And I have already discussed this on the example one slide, that how this function works. You have to write language PL PGSQL. The holders over here, or the pointers that start the function body is $, and then also have written $. If you want to use some other quotations here, you can also specify some custom quotations. Like sometimes I want to write here, let's say EDB, so I can type in here EDB directly. Sorry. So I can say here EDB and return, the ending of the quotation is also EDB. So instead of $$ quoting, I'm using here $EDB and $EDB quoting for the ending of the function body. This can be used. Let's save it, and let's now run it on our server. To run this script on the server, you can say psql-f script name, and I want to run it on EDB store database using Postgres user. So the function is created. That $EDB script worked. By default it is $, but you can change it to your own custom quotation also if you want. Okay, let's go inside and run this function. So I'll go and connect with PSQL database here, and we will say \df. You will see a new function there, SumVal, which takes two arguments I and z, and it will return you a numeric type. So you can say here select name of the function, sum_val, parameters, let's pass him 1, 2, press enter, 3 is the sum. So this is how you execute the function that you have created. Again, I can show you the script file here by using cat command here, !cat sum_val.sql, and that file contains create or replace function SumVal. The function was created. I didn't declare any variable here. I only declared two input parameters for this function, and whenever I pass those two input parameters, they are added and it returns me the total of those two input parameters. And the input parameters must be numeric. If you try to pass something wrong here to the function, it will give error message that the parameter is not found. So if I say here a comma b, let's see what happens here. It says invalid input syntax for type numeric a. So it is invalid input. So this is how you can create a function. Now I'm going to run the second function also here, the example 2 here that I have created there. So let's take a look at that example first. So the second example was differ.sql. So I can run that script also inside my server using \i. I'm already connected, and I can simply say here differ.sql. This will run the script, and I can show you the content of this script also. So create or replace function, differ, two values as input, and this time I'm declaring a variable. The name of the variable that I declared is d. No value by default. Then I say capital D is : equals to x minus y, so the value of the difference between x and y will be given to d, and then I'm displaying that value on the screen. Previously, in the previous function, I'm not displaying any value on the screen, so it simply says me the function name in the column list, in the column name, and then it shows me what is output 3. Let's now run this function and see what is output in this time. Remember, return is void, so it will be returning nothing. That row where previously it returned me the sum, now it will return me nothing, means it will be blank. This particular row will be blank. So let's run this function, differ, with parameters like 10, 5. And the message is there, that is raise notice message is there, difference is 5. So I got my output, and then it says differ nothing, means no row return, the null row return, because it is returning void, nothing. So this is how you can create a function with variables, and then you can assign a value using colon equals to operator. This is the expression that is assigned, and then use raise notice to display that value on the screen, and then close that function. And this is how to invoke the function. So that completed this particular demo, in which I showed you example 1 and an example 2 that I have already discussed on the previous slides. By this time in this training, you must be able to create a PL/PGSQL function with some parameters. You must be able to return a value using a variable. You must be able to do some expression and return that value. You must be able to assign a value to a variable, because we have covered all these topics so far. Now moving on to the next step, that is adding some control structure inside our PL/PGSQL blocks. So control structures actually can change the logical flow of the statement. By default, if you don't have any control structure in a PL/PGSQL block, the block will run from top to bottom. Once it reaches end, the function is finished. But in some cases, we want to run statements based on a condition. We want to run a particular update statement only if the salary of the person is less than 1,000. Now that means I want a conditional execution of a particular statement. Now to add these kind of capabilities, PL/PGSQL introduced control structures. There are three main type of control structures available in PL/PGSQL. First one is if statement, second is case expression, and the third one is loop control structures. Let's learn them one by one. If statement. This is one of the popular statement in programming languages. It can be used to perform actions based on a condition. The actions are performed when the condition is true or the condition is false. That means if works with a Boolean expression, and if that Boolean expression is true, some actions can be done, and if that Boolean expression turns to false, then the other options can be done, other actions can be done. So it adds a conditional statement, conditional execution capability inside PL/PGSQL. The syntax is given on this slide. You can use if, that is a keyword if, then the Boolean expression that you want. Now this Boolean expression can look like sal greater than 0, can look like name is equals to, in single quote, that name. It can look like you want to use a particular operator, like if this minus this is less than this, you can use that kind of expressions here. So if and write a Boolean expression, that means the entire result of that expression must be either true or false. Then again a keyword, and then you write the statements that you want to execute if this condition is true. So if Boolean expression, then the statement that you want to execute if the condition is true. If the condition is false, then it moves on to the next part. In the next part, you can either write else if, or you can say else. If you write else if, you can actually write another condition. So you can say else if, or you can also write else if. ELS if is actually an alias of ELSE if. Then you write Boolean expression, then you say statements. So you can add multiple if-else conditions inside here by using ELS if. You can say first if, and then second else if, third else if, fourth else if. Once you write all the conditions, you need to write at least one else. Now this is not mandatory, you can skip this. As you can see, all these are inside square brackets, and that means they are optional. If you even write single if and then Boolean expression and then statement and then simply say and if, that also works fine. The statements will be executed only when the condition is true. There is no else, that means nothing else will be done. So normally we write else, and inside the else we write those statements which will execute when the if condition goes false. And it is the same thing that we actually might have learned in other programming languages like C, VB, .NET or Java, and we use if else there also, and same way we can write that inside PL/PGSQL also. Example. In this example, we have a function dis_cus This function can be invoked using one parameter, which is customer ID parameter. So you pass a customer ID to this particular function, and what it does is declares a record variable. Now record variable can be defined using a record keyword, or you can say table name dot row type. So you can use row type syntax also. A record variable stores the entire row. It is different from a normal variable because normal variable stores one single value, whereas record stores the entire row that consists of multiple values, and it consists of multiple data types also. After that, begin. There's no semicolon after begin, then select into. Now select into statement is used to retrieve data from a table and store it inside the variable. So assigning a value to a variable using select into. So select into rec variable asterisk from customer, where cust id is equals to c underscore id. Now cust id here is a column name, whereas c underscore id is a value that you will pass. Keep in mind that cust id name of the column must not be equals to the name of the input parameter. They must not collide. If they collide, then it will not work. The function will not behave as it should behave. So make sure your variable names, which are input parameters, are and your variable names inside your function are different from the column names. Now once you run that select into, after that we are using here if. So we are saying if found. Now found is a keyword, is a local variable which will be true only if the previous statement has returned at least one row. So if the row is found, if that customer is found, then you say raise notice name of the customer, raise notice account number of the customer. If that customer is not found, it will go to else. So if found is false, then automatically the else statement will execute. Inside there I'm giving a message no data. And if, that is a end of the if, semicolon after that, return semicolon, because we are saying return void, nothing is returned. End of the function using end statement $$ language PLPGSQL semicolon. So when you execute this function using a particular customer ID, this will return you the name and account number of that customer. If the customer is not found, the message will be no data. So this is an example of record data type and of if else condition. Now I will show you a demo in which I will use if-else statement, as well as we will talk about other topics also that we have covered in the previous slides. Like I'll show you how to use found keyword, how to use a record data type, and how to retrieve a row from the database inside a record variable, and then later how to view the data from that particular record data type. So this will be a demo of all the things all together. So let's connect with the database here. I already have written the script which was given in the previous example slide. So I'm just going to use that script here. I have written it inside if-else.sql, and I'm going to show you the content of this file. So it contains a script create or replace function. This script is given on the slide also. The function name is dis_cus. It will ask for a customer ID, returns void, nothing, so nothing will be returned, as $$, so this marks the beginning of the function. Declare, inside the declare section I have declared a record variable, and then begin, select, and I'm retrieving the data inside the record variable, and after that I'm checking that found value, and then I'm displaying that content using the raise notice. So I have already explained this on the previous example slide. I'm going to run this now and show you how it works. So let's run this script, and the function is created. Now to invoke this function you have to pass a customer ID. I already have customers table on my server here. Let's verify that. Okay, so I don't have a customer table. I might have a customers table. Yeah, I have a customers table, and customers table have a cust name, no first name, and account ID, no customer ID. So I have to change the function to make it compatible with my database table. So let's edit the script here. So I'm going to say \e if else dot SQL, and going to change this to customers. Customer ID is equals to CID, that will be passed by user. So I'm verifying this thing, and let's display here customer name. The column is first name. I'm just making the changes so that it can work on my customers table. And the second value, okay, let's display here the credit card. So credit card, I can write here credit number. So two columns will be displayed out of the entire result set. Remember, rec variable will contain the entire row for that customer, and I'm displaying only the name and the credit card number for that customer. If there is no data found, it will display no data. Let's save it, and the function will be recreated. That's the beauty of create or replace function, because if the function is already there, that will be replaced. That's why most of the times I prefer writing create or replace function statement instead of just create function. But some people do write create function just to ensure that they are not deleting any existing function. And Postgres does support overloading. You can create same function again and again with different parameters. That is possible here. So now my function is created. Let us invoke this function. The name of the function is cust_dis, and I have to pass a customer ID. Let's pass 1. Press enter. It's dis cus. Okay, so the information is here from the table for customer ID 1. If I say here 100, it displayed me the customer ID 100 information. 1000, it displayed me information for the customer ID 1000. So this way this function has been used for table customer. Again, I can show you the syntax of the function that I have updated. I have edited the syntax which was already on the previous example. So I have changed it to select into REC star from customers, where customer ID is equals to C_ID. Then raise notice, display the name and the credit. Now I'm going to change this variable to row type, because row type variables are also supported inside Postgres. You can declare a variable of a particular row type. A record variable can store one row of any table, but if I declare a variable by using this syntax, when I say table name percentage row type, and if you are familiar with Oracle PLSQL, you already know what row type means. And we also support type data type. So if you say table name dot column name percentage type, so that will be a column type. That is also supported. So row type means only a one row of this table. Let's see whether this function works fine or not. So let's save it. The function is recreated, and let's run this function. With 1000, and it is working fine. You can see the function is working fine even with the row type variable. So even when you declare row type, it works fine. And I have used here a found keyword. You can also say if not found. So if you want to just write everything inside the else, or if you say if not found, just exit from the function, you can do that also. So this is an example of how to use if else, how to use record variable, row type variable, how to use found keyword, how to retrieve a row from the table and store it inside the rec variable, record variable, and then how to display that data using the raise notice commands. So that completes this demo. Case expression. A case expression is similar to if else. It can be used to perform conditional execution of the statement based on a Boolean condition. You can perform some work. It also have a method that you can write a selector name inside case, and then you can match the values of that selector inside the when clause. The syntax of case is given on the slide. you say case and then the search expression, or you can say selector and when, and then you give that expression here. So if that expression matches with that, if the selector matches with the when value, then the statement inside that particular when clause are executed. And you can specify multiple whens here. At the end of the case, you can also specify one else. That means if any time the condition did not match any of the when clauses, it will automatically go to the else statement and execute those statements. After that, you can end the case using end case statement and semicolon. This way you can define a case expression. Let's look at an example. Here is an example of case and when statement. Create or replace function dis underscore temp, that is the name of the function. Input parameter is numeric value tem. This returns a varchar as, then you start the function using $. You're declaring one variable msg varchar. After that, begin block. Inside the begin, you're simply writing case, and you're not using any selector or search expression. You're simply writing when right away after that. So case when condition, then do this. So when first condition is met, that is temp is less than 0, message will be icy. When temp between 0 and 10, so your condition is like that, you can say 0 and 10, the message is colon equals to cold. If temp is greater than 10, it's normal. And if none of them is matching, that means sometimes people pass a null value, or sometimes people pass some arbitrary value which cannot be matched with any of the when conditions. It will go to else and it will display message cannot determine. End case semicolon, so end case is ended. So there is no selector, no search expression, simply use case when. You can another example is you can retrieve the value of temp from a table, and then you can say here case and give that selector name in which you have selected the value, and then you can say when. You can specify 1 2 3 4 5 like that. For example, if you want to display a message based on the grade the person has got, so you can say if the grade is A, then you can specify some values there. Grade B, give this value, give grade C, and so on. So then you can see a selector and expressions there. In this case, it's simple. A value temp is passed and we are verifying that value. It's like we can do this using multiple if also, and here we are using case instead of that. To execute this function, you will say select dis temp and pass a temp. It will display a message IC over there. So this is an example of case where we use a temperature reading function which will actually read the temperature, and we have to pass the temperature. So if we say -10, it's icy. If we say between 0 and 10 any value, it will say cold, and if we say greater than 10, it's normal. So this way you can use this kind of case expression inside PostgreSQL PLPGSQL functions. Let's see an example of the case statement that I have written on the previous slide. So I have scripted that inside a script file. The script file is casewhen.sql. I will run this script on my server, and this will create the function for me, which is a dis underscore temp. Let's see the content of this file. And for your information, I'm connected with Postgres user with EDB store database. So using the Postgres user, I'm connected on EDB store database, and inside EDB store database, I will create this dis underscore temp function. So the statement is create or replace function, as I have already defined this in the previous example slide. So I'm going to run this and verify that everything works fine. So let's execute it by using \i. And the script file is casewhen.sql. Run it, and it has executed successfully. Let's call the function dis underscore temp. Let's give a temperature reading of 34, and it says normal. Let's say 10, and it says cold. Let's say -20, and it says icy. so it is working fine. So this is an example of case statement where I have multiple when conditions, and depending on the conditions, depending on the value that you input in this function, it will display the temperature reading. So if it is less than 0, it is displaying icy, it is working because I passed him -20, and -20 is less than 0. If it is between 0 and 10, it is giving me cold, that's working. And if it is greater than 10, it is giving me normal. And if you pass some value which is not matching with any of these conditions, it will display cannot determine. So this is an example of case statement. Loop statement. This is a control structure in which we can execute a set of statements again and again until it reaches an exit condition. So loops are mainly used to execute statements repeatedly until an exit condition is reached. In PostgreSQL, there are 3 different types of loop structures available. The first one is basic loop. The second one is while. The third one is for loop. Let's discuss them one by one. Simple loop, also known as basic loop structure. In this loop structure, you want to perform some statements, some actions again and again without any condition. So there is no condition to enter in that loop. The server will, the PLPGSQL program will by default go in that loop and perform that action. Now, as I said, it is automatically going in that loop, so there must be some exit point. If you don't specify any exit point inside this simple loop, then it will go for infinite, and that is not right programming in PostgreSQL. So make sure that whenever you are using simple loops, you are writing exit inside that simple loop. Otherwise, keep in mind, it will carry on again and again infinite time. So loop, basic loop can be defined using LOOP word. So you can say loop, which marks the starting of the loop. No semicolon is required after that, and what statements you want to run. So write those statements and make sure you write exit in there. You can write exit in different ways. You can say exit and when, and you can specify a condition there. Or you can say if the condition, then exit. Simply write exit keyword, semicolon, and end if. So in that loop, there is a if condition that if anytime that if condition goes to true, it will get executed and you exit out of the loop. So you can use exit directly, or you can use a if statement inside the loop statement to actually exit from the loop. It's the same thing that you are doing. Let's say you are doing a do loop and you don't have a condition to go in there, but in case of do also we write at least one condition at the end with a while. But here we don't have a condition to enter inside the loop, so there's not a conditional loop. It is simply going inside there without any condition. It's like you're writing while true. That means you are inside there, and true while is always true. So it's that kind of statement that you can write. Let's see an example in which I will display a series from 0 to 10 using simple loop. So a numeric value 0 to 10. Create or replace function dis, parenthesis start and close, no input parameter, returns void, nothing is returned, as $. Declare. REC variable is declared with a numeric data type. Begin. REC is initialized using 0, so REC colon equals to 0. Loop, so the loop starts. Raise notice, percentage, that is REC, so I'm displaying displaying 0 because that is the first value. Then I say REC colon equals to REC plus 1, so add 1 inside REC. This is how you add 1 inside there. Then exit when REC greater than 10. Right now REC is 1 and it is not greater than 10, so it will not exit. So it will only exit when REC is greater than 10, not even equals to 10. It should be greater than 10. End loop and return end $, language PLPGSQL. Execute this function. You will see that the loop will carry on that raise notice again and again. So the raise notice statement will be executed 10 times because 11 times because it will display from 0 to 10. So that way you can use simple looping structures. Let's run the previous example script on the PSQL terminal here. I have opened a connection with EDB store database here, and I'm going to run the script which I already have created for the simple loop. So the script is located inside my present working directory and named as simpleloop.sql, and I'm going to run that on my server. This is a script, and it is exactly same what is written on the previous slide in the example there. So let's run it on our server, and this will create the function. So the function is created. Now let's invoke the function by saying select and name of the function. No parameters required. Press enter, and you can see it is displaying 0 to 10. In the script I have written declare a variable of numeric type, and then I assigned him an initial value, and I displayed that value in the loop, and it will display 0. And then it adds 1, and then it verifies whether it is less than whether it is greater than 10 or not. It is not, so it will not exit. It will keep in the loop, and it will display 1, 2, 3, and so on. Once it reaches 10, it will reach here, add 1 inside it, and then it will say 11, and 11 is greater than 10, so this will exit. So this is an example of using simple loop. While loop. This is the looping structure which will perform the iteration based on a condition. So it will go inside the loop only when the condition is true. Anytime the condition is false or it is null, it will exit that loop. The syntax is given on the slide, while, that boolean condition, and then you write loop, and then you write the statements and end loop. So inside there we don't need to write exit unless we really want to. So this is how you can use while statement or while loop inside PostgreSQL. Let me show you an example of this. Here is an example of while loop. In this example, again I'm going to display series 0 to 10 using while loop. So create the function, return void, declare the variable, assign the value to the variable. So initialize that variable to one value, that is rec colon equals to 0. Now how to write while condition is rec less than equals to 10. Then loop, raise notice, display the rec, increase the rec, and end loop. So this will again go inside that while loop, go in that iteration again and again up till the time that rec less than equals to 10 is true. Once that rec less than equals to turns to false, it will exit, it will not go inside that loop. You can execute this function using select dis. So this is an example of while loop. Let's now run the script that I have created on the example slide of the while loop. So I already have entered that script inside while loop.sql, and I'm going to run this file. First of all, you can take a look at the content of the file. So it is a create of function dis1. I have changed the name of the function to dis1 because I already have a dis function which I created in the previous demo. So I changed it. Declare, I have declared the variable, then I have a variable initialization here, and then I'm displaying the value of rec, and then I'm saying increment the value by 1, and then it will loop through that particular increment and display me the value 0 to 10. So that's how it should work. So let's run this function here. So I'm going to say \i and run while loop.sql, and that will create my function. So this script is executed on the server now, and the function is created. Let us run the function. We'll say dis1 and enter, and it is working fine. It is displaying me numbers from 0 to 10. I can add some more thing, like I can use continue inside there, and I can also use exit if I don't want to display numbers after a particular number. I can do that. Now continue and exit are quite useful. Let's say that you are processing a huge set of rows and you want to skip all the registrations of a particular city. So what you can do is, when you're traversing through that particular set of rows using a record variable one by one, you're traversing through the entire data, you can actually say continue on a particular city. When you say continue on a city, all the statements under that continue in that loop will be skipped, and it will go back to the next particular city. So you can use this kind of keywords which are available in PostgreSQL PGSQL also. Let's take an example here. Let's say I want to skip number 5, but I want to display from 0 to 10. So how I can do that? I'll just go inside there and edit this file. I'm going to change the same file here. So edit the while loop.sql. So first of all, I'll raise the notice and display the value 0. So 0 will be displayed, then it will go inside the loop. After that, I'm just going to remove this line from the top here and add this line after the increment. So I removed that increment line from the top and I displayed it after the increment. That means it will display 0 and then it will increment 1 and display 1. After that increment, it will not go outside the loop, it will go in the same loop again and again. Now at step 5, when it reaches 5, what I want to do is I want to skip that. So I'll say here continue when rec is equals to 5, and this should not display 5, but yes, it should go to 6, 7, 8, 9. So it should not exit the loop, it should actually only skip one number, that is 5. When I say skip this, that means the next statement will be skipped. So all the statements after this continue up till the end loop will be skipped, but loop will not close off. Okay, that's what will happen. So let's save this and it will recreate the function for us, and let us run it. So we'll say here select the IES1, see the output, and you will see a missing 5 there. So same thing you can do with the cities, as I said in the example, that you can skip the processing of all the records for a particular city. So you can say there that you are retrieving the data, and when you say rec.city is equals to this, and then you can simply say continue in that case. So continue takes a Boolean expression, and whenever that Boolean expression is true, it will skip. You can even say if, and then you can specify Boolean expression, and you can simply write one word continue. That is also available, same way like you might be writing in other programming languages. So you say continue only, you don't write when with the continue, but here when is also available. But if you just want to write continue, you can say there if and then statement, and then you can say continue. Another thing that is available is exit statement, and you have already seen the exit statement inside the simple loop where we used exit to exit from that loop. And that is the same way while loop, we can use that exit in the while loop also. Let's say that I want to skip 5, but I want to stop at 8, means I don't want to display 9, 10, 11. So what I will do is I'll edit this function. So let's say \e while loop, and this time at the time of continue, just after that I'll say here exit when rec is equals to 8. Wait, I just want to display 8. So if I don't want to display 9, 10, I want to display 8. So whenever it is 9, it will exit the loop. So let's save it and run it. You will see it is 0 to 4, 5 is skipped, 6, 7, 8, 9, 10 is skipped. It ends the loop. So this is example of while loop, and I showed you how to use continue and exit keywords inside the while loop. For loop, the execution is similar like while loop, where we say while and then the condition, and then we enter inside there and perform our statements inside the loop. Here in for loop, we iterate inside the statements inside the loop using a count. So inside the for loop, at the top we define that what is our start expression, where we want to start. So variable name and the start value and the end value, and then we define the loop statements. The syntax is given here at the bottom of this slide, that is for, then the variable name in. Now the start value dot end value. That's how you specify values. Again, for variable name in the lower bound dot dot the upper bound, and then you say loop, and then you write your statements. In case you want to write the upper bound first and then the lower bound, you can say reverse. So you can say for variable name in reverse and then upper bound dot dot lower bound. I'm saying here upper bound and lower bound. These are the numeric values which will be the highest and the lowest count of that particular counter on which we want to iterate inside the looping structure. I'll show you one example of loop now. Here is an example of for loop in which I will display a series of number from 0 to 10 with an increment of 2. So it's a sequence from starting from 0 and ending at 10, but the increment is 2 instead of our regular 1 increment. So I'm saying create or replace function dis and then returns void as declare rec variable is declared. Now use that rec. Remember, in while loop we have to initialize that variable to 0. Here we are not initializing it. Here we are saying for rec in 0 dot dot 10, automatically this variable will be initialized. Automatically it will be incremented also, because we are not going to add 1 inside our loop structure here. If you remember, in the while loop we have to write that rec is equals to rec plus 1 inside the looping structure, then only it gets incremented. But in case of for, everything is done inside the for syntax at the top only. So for rec in 0, that is a lower bound, dot dot 10, that is upper bound, by 2. By 2 means you are incrementing by 2. If you say by 3, increment by 3. If you don't write any by syntax, by default the increment is by 1. After that you write loop, no semicolon. After that you write raise, whatever SQL that you want to execute inside there. I'm executing raise notice and display rec, end loop, return, and then language PLPGSQL. After that you execute this function, it will display the sequence from 0 to 10 by the increment of 2. Let's see the for loop demo here. I'm connected with EDB store database using Postgres user. I already have written the for loop.sql file, inside which I have written a create script which is exactly same that is given on the previous slide. So I have copied it inside for loop.sql script. I can show you the content of this script. So it contains that create or replace function. I have named it as dis1. I do want to change the name to, let's say, dis2, because I already have dis1 function here. So let's edit this file and change the name to dis2. So it contains that declare variable and then a for loop which will display the number from 0 to 10, and it will be incremented by 2. So let's save it, and this will create the function for us. So this function contains a for loop. Let's run that function. So we can simply write select dis2 and enter, and you can see it has displayed 0, 2, 4, 6, 8, 10, and then exit that for loop. If you want to reverse the order, you can change the content of this file. Let's say for rec in reverse, and then I'll say here 10 dot dot 0. So from 10 to 1 and decrement by 2. Let's save it. The function is created. Let us call the function, and you can say it is 10 8 6 4 2 0. So it is in reverse order. I used their keyword reverse. So this is the for loop demo. Here is another example of for loop. This time we are going to traverse in a customer table data. So create or replace function dis underscore cus, no input parameter, returns void as $declare. Declare a variable because this is a table and we want to traverse in the rows. That means we want to move on to the next row and next row like that. So we can do that by using a record variable. A record variable can store one row at a time. It's not going to store the entire table data, only one row at a time. So rec record, declare that variable, begin. Inside begin statement, we have to say that for variable name in upper bound, lower bound and dot dot, then upper bound, and then we say loop. Instead of that, we are writing here for record variable in query. So this is actually for query. It's not a for and then a count here. It's a for query statement. So we say for rec record variable in query. The query is select star from customer. This is going to retrieve all the data from customer table. Then we say loop raise notice customer name account number. Now, the name of the columns that are there in the table, you can use those names and refer them using that record variable. You can say rec dot column name that you want to display. So you're displaying name of the customer and account number, and then end loop. Once you execute this function, this will display all the rows of the customer's table. So if there are 10,000 rows, it will display all 10,000. For this example, I have used customers table, but in case you have a huge customers table, don't use this example. You can simply say select star from customer where customer ID between this and this. So you can specify a small range so that the data that is displayed there in the output is visible, and you can easily go through that. So you can actually amend this particular example if you want to run it on your systems. Let me show you this example now. Here is a demo for the for loop with a query. I have written a for query.sql script here, which contains a function that is given on the previous slide also, which will retrieve the rows from the customers table and show the name and the account number. I have made some changes in here because I have customers table. I have displayed name of the customer and credit card number. So let's see the content of this file, and we will execute it also. So we can say \e and for query. This way we can edit the content as well as it will execute that query on the server. So for query.sql, it is create or replace function. I change the name to dis_cus1 and rest is same. Then a record variable is there, and I've written here for rec in select star from customers where customer ID between 1 and 10, because there are a lot of rows in the customer table and I don't want to loop through all of them, so I just want to display from 1 to 10 IDs, so I can display that. And rest I have changed here first name and credit card. That's what what the column names I have in my customers table, and I'll run this query and it will display me the rows from 1 to 10, the IDs from 1 to 10 of the customers. So let's run this, and this will create the function for us. And now we can invoke this function by saying dis_cus1. And the answer is here. So you can see it is displaying me customer name, card number for first 10 customers. So the query was written in there inside the for loop. Again, I can show you the content. It is create or replace dis_cus, and the query was there. And for this query, the entire result set was created, and I traversed through the result set using the for loop. So this was an example of for query. Trapping errors. There are two types of errors that can occur in a PL/PGSQL function. First one is compile time. The second one is run time. The compile time errors are displayed right away when you run the create function script on the server, and that can be corrected, and you can rerun that create function script, and that will create the function successfully after you have eliminated those errors. Now, when it comes to the execution, when you execute the function and if there is any error at the time of execution, now these are some unanticipated errors. You think that the function will run successfully, but at runtime the function did not found any row. You got a wrong value inside a row, and you did let's say you divided it by 0. You got an array which does not have any value. So these kind of errors can occur at runtime because you don't know what the table will contain at runtime, and if the table contain nothing, what will happen at that time. So these kind of errors which occur at the time of execution are known as exceptions, and handling these kind of exceptions can be done very easily inside PL/PGSQL. For this you have exceptions block. You can declare your variables, you can write your statements inside a begin end block. Just before writing end, just before that, you can write the exceptions block. Exceptions block must be the last block inside a begin end block. So make sure that it is at the last. How you write it, the syntax is given on the slide here. It's exceptions when you can specify the condition, then you want to do this. Now, why you need condition? Sometimes you want to close the cursors, sometimes you want to perform the cleanup operation which is necessary before the function actually closes off. You can do that inside the exceptions block, because exception block is one of the block which will always execute before the function exits. So and it will only execute when there is a runtime error that occurs on the server. So if there is no runtime error, exception block is not executed. But if there is runtime error, then the server skip everything else and go right away to the exceptions block and execute whatever is inside that block. So you can display some meaningful message before you exit from the function, or you can do the cleanup. All that things can be done inside the exception block. You can use exception keyword to start an exception handling section inside your begin end block. Multiple exceptions can be handled using one single exception section. So the section must be at the end, just before the end statement. It must be the last one inside that begin end, and inside that section you can write multiple when this and then this. You can write multiple, you can handle multiple exceptions. Only one handler will be executed before leaving the block, so it's not like that you can handle two exceptions and both blocks will get executed. No, only one when condition will go true, and that will execute and it will exit after that. You can use when others to handle any type of exception. When others can handle any type of exception. That's why this must be the last handler inside your exception section. If you put it at the top, it will always go in there and exit. So no need of writing any other exceptional handler if you have when others at the top. So that's why it should be the last one inside that handler conditions. Sometimes it is important to know the reason behind the exception that occurred at runtime. You can get the information using two different methods inside PostgreSQL. The first one is special variables like SQL state, which contains the error code, and SQL ERRM that contains the error message. So SQL state, SQL ERRM, these variables can be sent back to the client. Like you can use raise notice and just display that, and that will actually tell you what type of error occurred and the message behind that error also. The second method is using get stacked diagnostic command. This is quite a useful command. You can write this command inside the exception handler. So you have an exception block, and then you say when others then, and after that you can write get stacked diagnostic, and then you can specify a variable name equals to item. Now here you can create a variable inside your declare section, and the variable value can be assigned here. So you can say the variable name equals to the value. Now the value can be assigned using different diagnostic values like returned underscore SQL state, or schema underscore name, table underscore name, message underscore text. So there is a table of this error diagnostic values inside the documentation, that what different values you can use, and you can assign these values to the variables, and later on these variables can be sent to the user or displayed inside that handler to the user using the raise notice. So you can display that value. So this way you can display the reason behind the runtime exception. Example. In this example, an exception at runtime will be raised if any time you pass the value of second parameter to be 0. So you get an exception which is division by 0. Create or replace function DIS two input parameters A and B, and inside there a result numeric parameter. Result is equals to A divided by B. So if you are passing a value which is, let's say, 10 by 5 or 5 by 1, that works fine. But if you pass a value like 5 and 0, that means you divide 5 by 0, then it will raise an exception, and then it will go to the exception block. And I have when others, so I'm not writing any exception name here, I'm simply saying when others, which can handle any type of exception. And then raise notice, wrong values for second parameter must be a non-zero value, return result, and close the function. So this return result will not execute unless your result is there, because it will just go away, it will exit right away after the raise statement. So this way you can use exception handling inside PostgreSQL. I'll show you some more examples in the demo on the next slide. Let's run the previous slide example on our server here. So I'm connected with EDB store database, and the slide example, I have copied it inside exception.sql file, and I can show you the content of this file also. So it is the same exact same function I have copied from there. It will return numeric, and result is numeric, and result will be A divided by B. So you have to pass two arguments. It will divide the first argument with the second one and return me the result. In case there is any error, it will display the error. In case of exception, it will give me some proper message on the screen, and then exit. So this I'm going to create this function, just an edit here of this file. I just want to add the name, edit the name here. I'll change it to 3, save it, and it executes that file. You can also execute this by using \i exception.sql. So this will execute that script, and dis3 will be created. So I can say here dis3, and let's pass here 10, 5. There is some error because the control has reached without at the end without the return statement, so I have to correct that. So let's edit this file here. I'm writing here return result because it has to result a numeric return a numeric value, and I will remove this return result from here. So it has to be done before the exception block, because exception must be the last block in there, and you can correct it on your side also. Let's save it, and let's now again call the function. So select dis3 10, 5, and the output is 2. That's what is an expected output of this particular statement. Now if I change it to 10 divided by 0, then I will see here a message displayed by the exception block which says wrong value for second parameter. So you can handle an exception, and inside the exception block you can display a meaningful message, and then the server will exit from that. Otherwise, normally you will not see what error happened at runtime. So exception block is quite useful, and normally it is always recommended to keep an exception block inside your PL/PGSQL functions. So that was a quick demo of how to use exception block. PL/PGSQL cursors. In PostgreSQL, we can create database cursors. Database cursors are pointer to the result set. They're used to encapsulate the query, read the result of the query when the cursor is opened, and later on you can use the cursor to traverse, to scroll up and down inside the result set. they are quite useful when it comes to large tables. When you are writing a query on large table and you're retrieving the data of the large table onto the web server, then it can cause memory overruns on the web server. To save you from such kind of problems where you are going to read large data for your reporting on the web server, you can use cursors in such cases, because you can encapsulate the query, read the result row by row onto the web server side instead of taking the entire result set to the web server. And this is only possible when you use cursors. To use database cursors in PostgreSQL, you have to declare cursor variables. Cursor variables must be of data type ref cursor. To declare the variable, you can use the declare section and create a cursor using a syntax where the first name must be the name of the variable and then the data type ref cursor, or you can also say name of the variable and then write the keyword cursor for, and then you can define the select query. You can also declare a cursor with a key, so that at the runtime you can send the key to the cursor and it will open the result set based on that particular key value. The first cursor that you defined, and in this slide also there is a cursor declared, that is cursor 1 ref cursor. This is unbound cursor. That means no query is associated with this cursor at this time. So later on I can open this cursor and use any type of query. I can use it for one query, then later on close it and use it for second query also. The second cursor defined in this particular slide is cursor 2, that is cursor for select star from tank 1. Now this is bound cursor. When you define a bound cursor, then that particular cursor cannot be used for any other query. It is bound to this query only. Whenever you open this cursor, it will open the result set, that is select star from tank 1 table. The third cursor that is defined here is cursor 3, that is with the key value. So when you open this cursor, you have to pass a key. And the cursor is select star from tank 1 table, where unique 1 equals to key. So you are actually opening that cursor based on a key. For example, you create a cursor on employees table based on department. So you pass the department key and then it will open all the employees result set based on that particular department. So this way you can define a cursor. Whether you use ref cursor data type inside the declare section or not, all the cursors are always of ref cursor type. When you declare a cursor, at that time you can also specify whether that cursor will be scrollable or not. This can be done just next to the cursor name. For example, I can say curse1 space scroll space ref cursor. So that cursor is scrollable cursor. I can move up and down. I can define curse1 and then can I say no scroll. So that means I cannot scroll up and down in that cursor. So you can do that at the time of defining the cursor inside the declare section, or this scroll option is also available inside open for query. That is when you open the cursor. Now coming back to the cursors. So first thing that you do for using a database cursor is declare that cursor variable. Once you have the cursor variable, the next thing that you have to do is open the cursor. Opening the cursors means you are loading the data inside the cursor. When you define a cursor, it's just a pointer pointing to nothing. If it is bound, it can only point to that result set. But you have to load that result set, and then your cursor will be active, and then you can fetch the rows from there. So the second part is very important here. When you open the cursor, this is where it acquires memory and loads that data inside the memory. So the cursor can be opened using open for query. You can say open the name of the cursor, for, and the query. Examples are given on this slide. You can see in opening cursors, it is open unbound underscore cursor for query. That means open cursor 1 for select star from FO, where key is equals to my key. So this unbound cursor is opened for a query. The query is select star from for table where key equals to my key. So this particular result set will be pointed by curs1. The curs1 was unbound cursor. Unbound cursors can also be opened using open for execute. So you can write a query open curs1, that is unbound cursor that we have declared of ref cursor type, for execute, and then in single quotes you can write the entire query. Now when you write open for execute, at that time the query will be built at runtime, because let's say you don't know the table name for which you want to open the cursor, and the table name will be passed at runtime, and this way you can actually declare a cursor and then later on open a cursor for a dynamic query by using open for execute. Opening bound cursors. Bound cursors can be opened by simply using open statement. You can say open and cursor name. For example, cursor2 is a bound cursor which we have declared on the previous slide. Here we can open that cursor by simply writing open curs2. So simply write open cursor2 semicolon. That will actually run the query which was declared for that cursor2, that is select star from tank1, and that will load the data and the cursor2 will start pointing that result set. Cursor 3 was declared on the previous slide, and I have copied that on this slide also. It was declared with the key. So at the time when you open cursor 3, which is actually a bound cursor with the key, you can say open cursor 3 and give the value for the key. For example, I give a value 42. So this way you can actually open a bound cursor. Once the cursor is open and it is pointing to the result set, now you are ready to fetch the rows from that result set. Whenever you use a fetch statement, it will fetch the current pointed row by the cursor. So wherever cursor is positioned, that particular row will be retrieved, will be fetched inside the target variable. The syntax for fetch statement is fetch cursor name into target variable. You can also specify the direction here. You can say fetch, and then you can specify last, you can say next, you can say previous, you can also say absolute 10, absolute 20, that means the 20th row, 10th row. You can also say relative 10, relative 20, that means wherever it is positioned from this position, next 10 row. You can also say forward, backward. So these options can be used. You can say fetch, and then you can write last from and cursor 1. So this will fetch the last row from the cursor 1. Or you can say fetch relative and then say 10 from cursor 1. It will fetch the 10th row from the cursor 1. So fetch statement can be used with the direction to fetch the row from a cursor into a particular variable. Another statement is available to fetch the data, to move the cursor from one position to another, that is move. You can say move and then you can specify the direction. Again, you can say next, previous, first, absolute, and the count of that row, and then you can say cursor name. So you simply say, let's say I want to move cursor to the first row, I can say move first cursor 1. It will move to the first row. So fetch and move can be used to traverse through the data. So once your cursor is opened, use fetch statement to traverse in the data, fetch the rows and use those rows, and once your work is done, time to clear the memory. And that can be done by using closing of the cursor. To close a cursor, there is only one statement available, that is close and the name of the cursor. Nothing else needs to be done. Simply write close and name of the cursor. This will close the cursor and release all the resources which were earlier taken by that particular cursor. So this way we can use the cursors in PostgreSQL. Again, whenever you want to use the cursor in PostgreSQL, you have to declare the cursor, then you have to open the cursor, after that fetch the rows, and then finally close the cursor. These are the four main steps required for working with database cursors inside PostgreSQL. Example. In this example, we will fetch rows from customers table and then display name and account numbers. So create or replace function returns void declare. Inside the declare section, I declared a cursor CUR. It's cursor for select star from customer. So it's a bound cursor which is bound to select star from customer query. After that, I also declared a rec variable so that I can fetch a row from customers table inside that variable, that is rec begin. I already declared the cursor, so I have to open it, and it is a bound cursor. I can simply write open statement. So I'll say open CUR and it will open the cursor. It will actually start pointing to the result set. Now time to get the query. So I'll say fetch CUR into REC. This will fetch one row inside rec variable. While found, now remember I want to traverse inside the cursor, and whenever I'm traversing inside the cursor, I need to make sure that once I reach end, I just want to stop there. I don't want to keep on reading, because after that there will be nothing. So what I have done here is while found loop, and if you remember, found is a keyword which will be true if the cursor has fetched at least one row. So if the cursor got any row and pointing to a valid row, the found will be true, and if found is true, I'll say raise notice, display the name of the customer, display the account number, and then I will again fetch the next row. So once I say fetch cur, I'm not writing here direction, and the default direction is next. It always move on to the next row. If I say last or relative, then it will move on to that particular row. But here I'm saying fetch cur into rec. So it will retrieve one row, the next row inside the rec, and again go to while found. And if the row is retrieved, found will be true. It will display that. Again move on to the next row, keep on going. Once it reaches at the end, the fetch cur statement will not return any row, and the found will be false, and it will end the loop. Once the loop is ended, right away I have written close cursor and then return. So this way you can declare a cursor, then open the cursor, traverse through the result set, and finally close the cursor. So this was an example how we can use cursors in PostgreSQL. Let's now see a cursors demo. In the previous slide, I have shown you an example which you can use if you have the customer table and those columns inside there, and if you have some data. When you run that example, it will run fine and it will display the data from customer table. And as it is displaying all of data, it has written select star from customer, so it is displaying all the data. In my case, I have a customers table which does contain data, but it have a huge number of rows, like near about 20,000 rows are there, and I don't want to display all of them all together on my screen. So what I have done is I have done a little bit customization in my cursors function, and I'm going to show you what I have made, what changes I have made, and that will display a little bit less amount of data, as well as it will show you how you can open a cursor with a key. So I've already written this script on my screen, on my terminal here. I'm connected with Postgres user on my EDB store database. So here I'm going to show you the content first. So let's take a cat command here. So I have written a cursor.sql file. Inside this I have written create or replace function. So the name of the function is same, but here I added one parameter with the function. In the previous example, that parameter was not there. So here I added one parameter, country name varchar, returns void as $, declare cursor. So I have declared a cursor with a key. It's a bound cursor with a query, but it is a cursor with a key. The key is CNTRY, and varchar is a data type for that key. For select star from customers table, where country is a column in my table, is equals to CNTRY. So the key is passed as a input for the where condition, where it will check that the country matches with that particular entry. Now when I open my cursor here, you can see that I have passed here the country name. So you have to write here CNTRY colon equals to. Don't forget to write colon equals to, because if you write simple equals to, it will give error message, because colon equals to is the assignment operator. So assign the key that you will pass a country name, and that will be assigned to the key when you open the cursor, and the cursor will be opened with that particular key. So these two variables are required here, and one column name is required for which you want to pass the key. Make sure that the names that you use for the key of the cursor and the name that you use for the input parameter is different from the name of the column. So they're different from each other as well as different from the column name. And then I have fetched the data and displayed first name and the city. So let's run this function on our server, create it, and then we will run it. So I'm going to write \i cursor.sql. So the function is created successfully. There is no error in this function, and I'm going to take a look at the name of the countries in my customer table so that I can pass a name here which is already present there. So let's write here so around 11 distinct countries are there inside my customer table. That means these the customers are from these 11 countries, and I want a list of customers from a particular country. I can specify that name as an input string to this function. So I'll write here select dis_cus, and I'll pass here input, let's say Canada, and you have to make sure that it is in single quote. Pass it and press enter. It will execute and it will retrieve the data using the cursor, and you can see it is working. So a lot of information there for the customers, and it has displayed all together all that information here. So this is how you can use cursors. Again, I made some changes, and you can see that changes on my machine here, and if you want to use a key cursor, you can use it on your machines also. So this was a demo about cursors, how to use a cursor and how to open a cursor, how to fetch the data, and later on how to view that information, and finally you have to close a cursor also. So that completes this demo. Database triggers. A database trigger is set of instructions or set of SQL statements that you want to run on the server before or after an insert, update, or delete event on the underlying table. This is quite useful when you want to verify or modify the incoming data, you want to perform some calculations, you want to perform a complex integrity check of or data integrity check of the data that is incoming on the server, or you want to restrict the user from deleting or from updating certain columns on the server. And in some cases, when you want to run further SQL commands after your insert, update, or delete on the underlying table. So there's a lot of functionality that comes with triggers, because they can be used to automate a lot of tasks that you want to run after the insert, update, or delete events. In PostgreSQL, when you have to create a trigger, you have to first of all define a trigger function. So you have to create a trigger function, and that trigger function must return a trigger type or null. Inside that trigger function body, you will write the set of statements that you want to execute when the trigger is fired. Once your trigger function is ready, we call it trigger procedure. So once that trigger procedure is ready, then you create a trigger on the underlying table by using create trigger statement. And at that time, inside that create trigger statement, you will invoke the trigger function. In other databases, you can simply say create trigger and what type of trigger it is, when do you want to fire it automatically, and you write the body right away there inside begin and end block. In PostgreSQL, it's a little bit different because you cannot write the body inside that begin end block. You have to create a trigger procedure, and inside create trigger statement, you will be calling that trigger procedure. Again, I'm saying trigger procedure, but it is created using create function statement. So first of all, you create a trigger function in a trigger procedure. Inside that trigger procedure, we have some special variables that are available, and these are only available inside trigger procedures. Variable like new. We also call them magic variables because these values are populated automatically and they are available to work on inside the trigger procedures. The new variable is a record type variable. A record means the entire row. Now, which row it is? It is newly inserted row. So whenever you are doing an insert, the row that you are inserting will go inside new record variable, and that will be available inside the trigger procedure. In case when you are updating, that means you have a row which is going to be updated, so the previous row will be deleted and a new row will be inserted. So you have a new row which is updated row and the previous row which is old one. So in case when you are updating, you will have a record inside new variable, because that's what is going to be kept inside the server. Old variable, when you are deleting a row, that goes to the old variable. When you are deleting a row, that goes to when you are updating a row, the row that is being updated, that will also go to old. So let's say that you are updating a salary of an employee from 3000 to 4000. So 3000 is the old value, that will go to old record variable, and 4000 is a new value that you are updating, and that will go to the new value. So anytime you want to perform an integrity check, that if I'm updating, you want to allow the update on salary column, but you don't want to allow to decrease anybody's salary, so nobody can get a decrement, and you want to enable that functionality inside your data table itself. And you can do that by using this new and old keywords, where you can verify that the new dot salary must be greater than the old dot salary. Anytime it is not, you can simply say raise error or raise exception, and you know that what happens when you raise error or raise exception, your query will be rolled back. The next variable is tg underscore name. This will contain the trigger name. So it is a data type of a kind of a varchar which actually contains the name of the trigger which was actually fired. Because here I said that you have to create a trigger procedure, and the trigger will be calling that procedure. So inside that procedure, if you want to know that which trigger called this procedure, because same procedure can be used by other triggers also here, because it's a function and function can be invoked by any number of users. So it can be trigger 1 invoking that function, trigger 2 invoking that function. So in case if you have such situations where your single function is used by multiple triggers, you can actually use tg underscore name to find out which trigger actually invoked this particular function. So which trigger was fired. That is what tg underscore name can give you. A trigger can be created to get fired automatically before or after the event. So in case you inside the trigger procedure, you want to know that was this particular trigger fired before or after that event. Now event can be insert, update or delete. So was it a before trigger or an after trigger, or in PostgreSQL 9.1 or later, was it before, after or instead of trigger? So these three values can be there. So you can actually find that event, that particular string which tells you that was it a before trigger, after trigger or instead of trigger, and that can be done by using tg underscore when. tg underscore when is a special variable which will tell you when this trigger was fired, before, after or instead of. The next is tg underscore level. Now triggers can be defined at row level or statement level. A row level trigger is fired for each row affected. So if you are running an update on the server and that update affected 10 rows, so the row level trigger will be fired 10 times. If it is a statement level trigger, then statement level trigger gets fired only one time. It's not 10 times, it is one per statement. In case of row level, sometimes trigger may not get fired. Reason: zero row affected. You try to update the row, but there was no row found, so it is zero row updated. In that case, the trigger will not get fired. But if that trigger is a statement level trigger, it will get fired even if it is not affecting any rows. because it is statement level trigger. So these two level of triggers can be defined at the time of creation of the trigger. We can specify whether it is a row level or statement level, and when that trigger is fired, it will call a procedure. Inside the procedure, you want to know whether it is row level or statement level, at what level it was fired. You can find that by using tg underscore level. And again, this variable is available inside the trigger procedure. The next one is tg underscore op. So this is event. That means when this trigger was fired. Was it fired at the with the insert statement, update or delete or truncate? So these four values can be there: insert, update, delete or truncate. tg underscore rel name. This will tell you the table name, the underlying table name on which that trigger is sitting, and that trigger was fired on that particular table. That is tg underscore rel name. The next variable is tg underscore nargs, which is actually arguments. So if your trigger is taking some arguments, all those arguments will be there inside tg underscore nargs. There is also a variable named as tg underscore table underscore name, which can actually tell you the table name. It's same like rel name. Another variable is there, tg underscore table underscore schema, which can tell you the name of the schema in which that table is on which the trigger was fired. So these are some magic variables which contain value, and these values are available for the trigger procedure to work with. As I said, you define a procedure, that is a function which returns trigger. So it is a trigger procedure that you have to define, and then you write create trigger statement, and in that create trigger you will say that call this particular procedure. So this particular procedure can be invoked by multiple triggers, and if such is the case, you might want to know that on which table it is actually getting fired, and based on that you can do the work. So these variables are available inside your trigger procedures. Database trigger example. In this example, we have a city table which contains city ID and population of that city, and we have a birth table which contains registration ID, name of the person, and the city ID in which the birth took place, in which that was registered. So what I want to automate here is that whenever a birth registration takes place in a particular in a birth table, based on the city ID in which that birth was registered, I want to increase the population inside city table. That should add 1 automatically. So we can create a trigger to perform such kind of automation on the database side. So if I say for this I will insert some sample rows inside city table. So let's say city 1 and city 2, population 0 0. Then you can view that data also. So it will show you 2 rows, population should be 0 at that time. After that you can create a trigger function. So create a function by using create or replace function, give it a name, returns trigger, as then the body says update city, set population equals to population plus 1. So I'm incrementing the population. Remember, I have to increment the population for only that city where the registration took place. So at the time of registration, person will give a city ID, and for that city ID I want to increment it. So I'll say here where city ID equals to which city ID? New dot city ID. As I said that we have a new variable which will be available at the time when you insert the row. New will contain the newly inserted row. So newly inserted row will contain city ID, and I want to update the row for that particular city ID by incrementing 1. After that I simply write return null and end the function. Now once the function is created, we have to create trigger also. Trigger can be created using create trigger function. So trigger has to be created on birth table. Remember, we want to update city based on the row inserted on birth table. So we'll say here create trigger, trigger name, after insert on birth. I want to make it sure that the trigger is only fired once the birth registration is done, not before that, because I don't want to fire that. I can do that before also or after also. So here it is after insert on birth table for each row. Remember, a person, we can have, let's say, single insert statement and 10 rows inserted. Or sometimes we use copy statement and we copy, let's say, 100 rows inside birth table. In such cases, we have to fire trigger for each row, because if we fire it for one statement, there will be 10 rows inserted, but only one incremented inside the population, whereas it should be 10 increments in the population. So that's why it is a row level trigger. And what we are doing, execute procedure, name of the trigger function that we created. Give that name, do some insert inside the birth table, and you will see the city will get automatically incremented. The population gets automatically incremented. So this is example how we can create triggers inside PostgreSQL. Let's run the example shown on the previous slide for the triggers on our server here. So I have created some files here, which is trigger function file, trigger tables, trigger test. So these files, I'm going to use them, and trigger create.sql. So I have already copied the scripts from the slide inside these files. So first of all, I need the trigger tables, the baseline tables here. So I'm going to create those underlying table using trigger tables.sql. And if you want to take a look at the content, you can see here. So it contains create table, city, birth, insert into city, no insertion inside the birth table, only insertion inside the city table, and select start from city. And let's run this script here, /i trigger underscore tables dot sql. So table created, 2 rows inserted, and I can see those 2 rows. Population is 0, 0. The next task that we have to do is a trigger function. So let's create that function here. Again, let me show you the content of that file here. That is trigger function file. So it contains a normal trigger insert function, which is returning trigger, and I have already explained that on the previous slide. So I'm going to run and create this function first. So let's run this script here, and this will create the trigger function. Now we will create the triggers on the table. So the trigger will sit on birth table, and whenever there is an insert on the birth table or any task on the birth table, it will get fired. So I have written that script inside the trig underscore create.sql. So let's take a look at that file here first. So it contains create trigger after insert on birth table. So let's run this /i and run this trigger function.sql, and this will create the trigger create.sql, and this will create the trigger on our server. So let's run it. So the trigger is created. Now my table birth contains a trigger. There's no trigger on city table. No trigger on city, it's on birth table. Now let's test this trigger. For testing this trigger, we will insert some rows inside the birth table, and I have written that script also inside trig underscore test.sql. So I have written here insert into birth values 101 Raj 2, and after that select on the birth and select on the city. So let's run this. So I inserted one row and the city ID is 2, and you can see city ID 2 is automatically increased by 1. If I run this again, the city ID, there are 2 births now, 2 registrations there, and it is increased by 2. So this is a very basic example. Here there is no integrity right now inside my registration table. I haven't created any trigger on the update, on the delete. For sure, if you have such tables and you are using triggers for implementing automation, you will be creating a trigger for update also, for delete also, and you will enforce a unique key also inside there in the registration ID table so that no duplicate values are there. And you will also enforce a foreign key integrity between the birth table and the city table so that the city ID is always matching with the cities that are inside our city table. So all that will be done when it comes to designing your entire data table structure, and then later on designing the automation part. So all together it will go all together. So this was a quick example to show you how you can use triggers. So that completes this demo.
We have completed this module. In this module, you have learned what are different procedural languages available in PostgreSQL, what is PL/PGSQL, how it works, how the block structure can be defined, how we declare variables using PL/PGSQL, how we write executable statements in PL/PGSQL, how we declare function parameters, what are different control structures, looping structures. We talked about exception handling also, and later on we talked about cursors in PL/PGSQL, how to define and use triggers in PL/PGSQL. With this, we have completed the module. Thank you. Lab exercise 1. In this lab exercise, you will create a function where you will declare two variables, store the date in these variables, and then you will display that date on the screen as well as return that date to the calling context. Lab exercise 2. This lab exercise is based on the scope of the variable. The function is declared inside the slide and you have to find the value of the variable at different block levels. Lab exercise 3. In this lab exercise, you will create a function which will copy data from existing products table into a new table known as sale products, and only the selected data should be copied. Lab exercise 4. In this lab exercise, you will create two functions. The first one will accept a price and delete all the rows for that priced item from sales product table. And the second function will use cursors and display the category and highest price in that particular category.